we'll go into a model, and maybe I don't think I'll be as articulate as Paul, but I'll try my best to give some meaning behind all the lines and boxes. With how we're doing modeling, ultimately, I think it's like a view of a map and a journey, right? As we're modeling across the traditional way of going through any environment for testing, everyone here knows, is going through happy paths, making sure your journeys are met, as Paul was discussing earlier. However, it's what we're trying to do now is not just to reach those standard paths and journeys, expand upon beyond that 1%, as Paul mentioned being covered, and how do you take advantage of things pre-built. I really like the analogy. So yesterday I was having a meal, and it happened to be two taxi drivers who were having a dinner together and having a discussion. And one of the topics we're learning about, if you're all familiar with London taxi drivers, is this really rare and unique skill set where you basically have to go through 30 days of like tests and rigorous years of training, so that way you can basically learn every street within London, right? You've got to go from Buckingham Palace all the way to North End or the theatre district, every major restaurant. And the test that you have to do is you have to give you point A, point B, you close your eyes and you have to mentally describe every single step, left, right, journey down the road, right? And that is why taxi drivers are so valuable. Well, before GPS and Google Maps and Uber. And now they're discussing the massive changes, the fact that now the modeling exists for maps, modeling exists for paths, modeling exists where what used to be this extremely rare skill that was nearly impossible for some people to learn, and where to turn left on when they go to the search and where to go right. If I'm laboring this analogy, now you have the model, right? And I think that's really the approach where data is going with testing as well. The fundamental nature of the model itself is not valuable, but what it is gives any tester a random Joe Blogs coming down the road and gets in the car now effectively should have a better knowledge of the street, efficiency, traffic, where to go and to avoid it than any taxi driver. It wasn't a very nice discussion to have with said taxi drivers talking about Ubers and how it's surely just better using the Waze app. But I think that's really around where modeling takes place. So I'm going to go through into this model here where this is just the design of, this is just the general view across it. And I'm going to jump into design and why mapping out matters. And I'm going to tie back into finding those clear paths that makes the most sense first, right? Because I think modeling right now, one of the major problems with modeling, we're still not quite there with like Waze, where we've got every single road, every single possibility, and it tells you, where there's a slowdown going down the line, there's a block and barrier, but really you still need that human in the loop with understanding where to build that model. Because if you go onto any website, this one is, our dummy website that we have on a e-commerce site, is just a WordPress application. Even something so simple and as a dummy site, it's ridiculously complex from a model perspective. This is just a very minimal view of what's possible across any modeling approach. And then for how do we prioritize them? So as we're building out these ones, we go two main approaches, right? I think there's generally a main approach we talked with our prospects and clients and so on. One is going from the more traditional development perspective. Right? You do development, you go into your agile sprints, you generally have a epic, you go for a user journey, you go for mapping. I think that works really well when you don't have the information you need, right? Because you're developing, you build up wherever you need to as it goes along. And that's how you actually map those perfect journeys where you start off and go, I know I need to go into the homepage, I need to go into search results, I need to go and so forth to some other random system. However, if you go by the other side where you have the Google Maps option, which is map every single journey, and then you build in the thing, I find the noise level is so great. You effectively can't map it out and you can't reduce it down to the modeling. I think I probably went a little bit off kilter there, and I'm happy to jump into if you want to go about how to create one of these items, how to map it out, the code behind. It's up to you.
I really like where you're going here, and I know this is a very experimental format for us, so I'll keep with this. And I really like the idea because to me, and I'm not an expert, but the kind of top-down approach versus the bottom-up approach is maybe there's two different ways to look at it. And so I remember doing the model for the London Underground and then hitting the big green button that said how many paths, permutations through the London Underground. And Paul, in his session, showed a map of the London Underground, right? And part of it is it started doing it, and then all the compute kind of kept on going, and the laptop froze for about a day, and then came back, and it was like 1 trillion combinations of, you get out of this path, you walk here, you get back on, you go underneath. And obviously, with the example I was kind of giving, we did the same thing. We took Google Takeout information of me walking around London, and then created synthetically thousands of different permutations of me going to Canary Wharf and then going on, disappearing off the map, getting the underground and popping out somewhere else. And, there's so many layers of complexity in there of, I'm going to use the Shrek analogy of onions, of lots of layers of onions of different states. And, what I was always impressed with apps like Waze, and things like other apps which would have a rain safe option, right? So if I want to get from A to B, but it's raining, i.e. the weather's there, that's a different state. It's going to give me a different route. But in the essence, it's still using the same calculation. It's just waiting to say, if there's a dry area, you prefer that unless I'm going to walk too far out of my distance. But I think that level of what I'm starting to refer as metamorphic testing is hugely complex. And that kind of Paul's and your viewpoint is that when you're talking to a customer, they may just say, well, what route would you recommend so I don't get wet? But the abstraction level of that is so complex that actually, when are you going? Oh, I'm going today. Okay, well, I'm pretty sure that it's going to not be raining. That's why you can ask Alexa, should I, take out an umbrella? But tomorrow there's less uncertain, there's more uncertainty to it. And so there's always a moment in time. And so I think people forget this, and they kind of look at it maybe from a bottom-up perspective of saying, I want to test, I'm going to just take an item off here, but I want to test the search. Now, we know search is incredibly complex, and the poor people at Google must be sat there every day going, oh my gosh, and I used to remember, Paul will remember this as well, but Alan Page, who used to run, who wrote the book on how Microsoft test, he used to always give this great example about Bing, when he used to work at Bing, that, they do 26 releases a day. And I was thinking to myself, 26 releases today in a continuous testing, that's amazing. And I was thinking, but it looks the same every time I go to Bing. Where's the new features that are coming through? But it was refinements to the search engine, refinements to, different functionality with the mapping overlays or whatever else it was. It's incredibly complex. But to us, a search is just a box with some text, which we know has some rules and some positive and negative tests against it to say, and I always defer off to probably people like Paul, who then use the bracket, widdly, squiddly something to narrow down the string to state, it must be 7 days old and all this kind of other stuff. But how do you kind of test something like search and then make sure you've got positive and negative tests that, you can't just pass a wild card in there, or the system breaks because you put hashtag, which I was going to change my middle name to, drop all tables or something, part of it, how do you do that, right? How do you model out that kind of different permutations?
Mm-hmm. With the permutation, I think that's a really good question, because ultimately, especially when they use the word coverage, which is probably the nightmare word every time we're phrasing, because it's always show me the coverage, and then once data is introduced, now you have an infinite variability in coverage because you now have language, you now have data sets, materials. One of the things that we've been almost moving away from is pre-making a data set for approach. So when you do a search term, you pre-make a data set that allows you to go through the journey. However, we're doing hybrid approaches now where we'll have a testing backend, except we look into the live production data and the kind of queries that come through and use that information itself. Because now, you have a extremely valid data set because it's literal data set that's being used during the search items, as well as the fact that you get the unreliability of a normal human. Searchers that's irrational, doesn't make sense, or they put a random object, search terms with breakout keys in your search for that you're never going to normally find. So I think that's a really nice hybrid approach that feeds in both the production world into the pre-production world, because although in theory you can always generate information, and we do this with effectively libraries and text or figure libraries that we know the range of, and we do a combination fields, which just makes the extrapolation for the model possible tests enormous and impossible to cover. by taking in the weird edge use cases, we can use those ones as some mesomorphic algorithms if it's a text space, if it's numbers, and we can just add in a range buffer that goes beyond what is required, and we can just alter those ones as the benchmark for what we're expecting. Also, that does give a little bit of a more efficient way of testing, because there's not as much as we like to test every single edge case, the most valuable test we should be really doing is what users doing 90% of the time, opposed to that weird 0.1% edge case, which if it happens, yes, we may lose a customer or two, but realistically, it's so rare. Why spend so much of your time and resources fixing?
So there's a couple of things here which I'm going to jump onto, which are my favourite conversations, which one of my friends called Paul Smith, which I think is the best name ever, especially in testing. Paul used to be the head of performance, I think, for John Lewis. And I remember sitting there having a drink with him, and I'm only saying that because you brought the shopping one up. And I said to him, how do you test all the different permutations in John Lewis? And he said, well, actually, and there's certain information I'll give it. He said, actually, there's only 26 main test cases, main core test cases. And he said, but the data is endless. But he turned around to me and said, but we use the most searched terms. And he said that was lingerie and electronics in no particular order, but you can guess. And, part of it is he then fed in those. So iPhone 6S, iPhone 7S, whatever it is. Sorry, they don't make it 7S. But anyway, so fed in all those terms. And then that would then tell the system. Now, we mentioned Happy Path here. And, in a way, that is Happy Path. You kind of know because the product does exist. Now, actually, I was chatting with Gareth yesterday on another call, and I said to him, when I've talked to the people at Tesco's who in Welwyn Garden and how they test the system, they have quite a different system that actually, if no one's ever searched for curry flavored baked beans, the page doesn't actually load. So it's a new load, right? It's generated automatically based on the database. It's not a page which is called baked beans, spicybakedbeans.html, right? It's dynamically generated. And they turn around and say, we got thousands and thousands and thousands of different products you could do in different orders, that actually it would be impossible to test all those permutations. So I'm going to kind of throw this over to Paul because, I did bore somebody for 3 hours when at Star West many years ago, when I did an entire tutorial on code coverage techniques. And I think what Ethan was saying kind of made me think is that we got a test coverage tab, which we will click on eventually, but it's just too exciting to build it up beforehand. But if we just take the search example and we say, what's the test coverage? My question would be, and it was kind of what I was getting when I was working with people at Apple and stuff. Part of it was, the buying of an app in the App Store is pretty straightforward, but there's millions of different apps within the App Store that actually the permutations of searching for an app, which you're trying to find, then download on your phone, that's really difficult. So they were always asking us, what's the data coverage? And this is where I'm going to throw it over to Paul in a second to see how you can rip me to pieces, versus test coverage. And really, is there a test data coverage aspect that kind of says, well, actually, we could spend forever going on this search one. And the reason I'm going to say that, and I'm going to shout out to the audience to kind of have things. So we see earlier, I demoed the MIT COVID contact tracing, and Stella was who's online at the moment. She was, or in the audience, she was actually heading up the testing. And I always felt really sorry for her, not only because it's incredibly stressful to deal with something like the complexity around testing games, Google and Apple exposure notifications, but secondly, she had to Randall Dorothy Graham, who was a volunteer tester, who spent most of the time ripping the developers apart by going through their documentation and kind of going, this requirement's wrong, this is wrong, you've not specified this. And she obviously went at a different point. She was less interested in about the UI, but actually the devil was in the detail of what the developers were doing, that she was actually really interested in making sure that was right. So many different directions to go at it. And my question to Paul now is, how would you define the test data coverage for something which has a near infinite value, like the permutations of COVID and locations? And the problem is, if you get it wrong, that people are going to have to self-isolate. You know, it's a pretty critical for people's lives. How do you provide the right test data coverage as well as the right test coverage? And is there a such thing? Because I generally don't know. And he's on mute, so he's on mute. So that way, when he gives the answer, he's going to say 42. It's kind of like, it's all right. It's 42 was the answer to the question. So I'm going to unmute you, Paul, so everyone else can hear you. You still need to click the happy button. What says yes, it's okay, Jonathan. I will unmute you. Still can't hear you. No, he's lost his voice completely. So I'm gonna unmute. He's not unmuted. You need to unmute.
I did. I thought you unmuted me.
Oh, you did it. I've done it. There you go. It's done. Go on, tell us the answer to it. It's not 42.
It's only a button that big, and anyway, whatever. Look, setting aside the obviously AI-driven searching to look for the meaning of words, not just the letters and the shape of the words themselves, but let's talk about just sort of text searching in documentation, which I've been doing a lot of recently. I mean, well, first thing is like, well, you could say, all right, if I provide a search string of 5 words, does it make any difference? Does it add any value if I put them in a different order? So you could say, all right, I could set up a scheme whereby I'm going to test the outcome of searches for 5 words in all the possible sequences that you could have. So I can write that down. I think 5 times 4 times 3, is that 60? So there are 60 possibilities. So I could have 500 strings and 500 times 60, which is 30,000 search strings, and then look at what I find when I submit these 30,000 search strings. Now, what's my expected results? Well, I certainly wouldn't go to Google to go and find my expected results. What I would do is I'd generate data based on the rules I'm trying to test. So I would write some code to say, generate 100, I mean, this is completely imaginary, but let's say generate, but Google could do this, generate 100 million documents with a phrase using these 5 words. And for each document, I want you to put in one occurrence of one of these 30,000 search strings. And I want to know when I do my search, because I've created these documents with these 30,000 search strings, I might do it such as there's 1 million documents, but only 30,000 occurrences of the words. So my expected result would be, do I get 30,000 matches when I submit these strings? Okay. For example, next question might be, okay, of the words in the strings I'm submitting, I want to get near misses. So for every word in every string, I want the transposition of 2 letters. So I might spell Google G-O-O-G-L-E or G-O-O-L-G-E. I get the sequence of letters wrong. Does it find that kind of stuff? Because actually what I want is near misses. And actually, I don't want to just transpose the 2 letters. I might just want to put an X in instead of one of the letters because I just made a mistake, or a decimal point, whatever. So I would write some code to generate content which had the word as I'm searching for and the word spelled incorrectly so I can match the search. So I might do it that way. And I might do that in combination with all the permutations and sequencing, all that kind of rubbish, and so on. But you can see how it goes. It's like, I think in the context of Google is that I don't think they say we've got 100 billion pages. We're just going to search them endlessly and someone's going to check it manually. That is not the way they work. I'm sure they generate test data using tools that uses the rules to create the data and uses the same rules to generate test cases that will match in a very precise way. And kind of, I don't know when I first did this, but you can, I can't remember what it's called now. It's like carbon dating. You know, it's like you can take live production data and say, right, I'm going to tinker with some of the content of this live production data in my test environment. And these are the good old days when it was easy to take copies of production, all that kind of stuff. but you can put some kind of junk data inside your test data and use that as a basis of doing searching, or literally tinkering with numeric values that are very odd. So if you've got values which range from 0 to a billion, well, you've got a billion possible combinations of data values there that you could do a search on, and so on. So you just have to use your imagination and say, well, look, what am I trying to prove here with my test? I'm not interested in having perfection. I'm interested in getting a response that tells me that it found the one record that I generated that it should have found. That's kind of the game you're in. By the same token, I mean, it's not the same as search, but testing autonomous cars. How are we going to test autonomous cars? Well, the test isn't that every car makes its way to its destination. Given a million cars in a simulation, all going from A to B, or A to Z, whatever it is. What you want to know is how many collisions there were, how many people got lost, how many people were delayed, how many people ran out of petrol, out of gas, and so on. And so these are the expected results, is that you want everybody to get home safely. That's the end of it. So you count the number of cars that you set off on their journeys, and you count the number of cars that arrived safely without driving through walls or each other or whatever, going down one-way street. So the criteria is kind of, it's like you just have, how you draw that model, I don't know. And it's a mental model right now because nothing is drawn down, but that's the game you're in. You've got to use your imagination and use software to test software. We've got to get into that game. Too often we think I've got to do it manually. I've got to do it in Excel, which is not software. Well, it is software, but it's not. You know what I mean? So I think things are possible. And with automation, it might be the only way you're ever going to get any reasonable testing done. And Google don't do anything manually, do they?
No, they don't.
Manually?
And Jason Arden, who I caught up with quite recently, and obviously James Whitaker, who wrote the book on how Microsoft test, right? And how, they wrote the book on how Google's test. Alan did the other one. But two things to that, which I think are really interesting. And so everyone knows this, or they might not know this. So in the UK yesterday, they changed the law to say that you're now legally allowed to watch TV whilst driving an autonomous car. So, but you're not allowed to use a mobile phone whilst driving an autonomous car. Now, this might seem like we're going completely off piste with this kind of thing, but back to my session, I kind of showed at CES that Keysight had launched a radar simulation testing equipment, right? So this big device which simulates up to 512 objects. No one had an idea why it's 512 as the limit, apart from we can all work out why. But anyway, the idea is it can simulate multiple people walking across the road, multiple objects simultaneously. Now, why is this important for autonomous driving compared to, well, Tesla does it all? Well, no, most autonomous cars at the moment test in the real world under circumstances which cannot emulate a dog, cat, pigeon flying across the middle of the car, because these are nuanced. And this is we can call it canary testing, by throwing a canary in front of an autonomous car. But part of it, and I must admit, there's a new series on Amazon called Upload, and they've got this autonomous car which crashes, and they said you've got your choice of prioritizing pedestrians or yourself, right? So part of it is your car is making an executive decision whether or not A, to continue to run over the pigeon/canary, or to prioritize the passengers on board, which seems a bit of an ethical dispute, which is the normal infinite question which everyone brings up with AI and bias, which is there's a self-driving car on a road, there's somebody in the right lane who's on a motorbike but not wearing a helmet, and on the left is a SUV with a baby on board. Does it sway left to crash into the baby car because the SUV's got the highest NCAP rating, or should it hit the guy on the motorbike because he's not taking his own safety into consideration by not wearing a helmet? So, the answer is neither of those decisions are made because it's not any of the information that the Tesla system's even processing. So part of that kind of infinite question is like, we've got things like Car2X, we've got infrastructure to X, which is learning by communicating and passing data between cars. So autonomous cars are exactly what they are. They work on their own thing, and they take radar and video feed to actually make a decision. Whereas once we got connected car and we got Car2X, it would talk to infrastructure. So like Aldi demonstrate, you can put your foot on the accelerator, and until the green sign goes, it will not let you accelerate. Whereas the Tesla would look at the side, the traffic light, wait for it to go green, and then allow you to accelerate. So, part of it is autonomous versus connected is really important in those kind of circumstances, which we'll skip trying to model out an autonomous car, but it is possible. And I did mention in my session about things like augmented reality and using, stereo to make decisions on what humans would make. But that to the side in that great law that says that you can watch TV. And the reason is because insurance companies are now taking the liability. And to your point, Paul, that is then, you've all seen why Tesla had to recall their latest autonomous driving capabilities, because this one corner in California, 2 Teslas went off in the same week and crashed into the exact same locations. And there was just a glitch in the fact that the variables on that particular area don't read correctly on the road, and therefore send the same negative solution off, but 2 Teslas crashed in the same period of time with a live over-the-wire update. So part of it is, how do you test it in the real world? How do we literally then say, these people successfully got to their journey, these people didn't, and then the question is there enough information by having the real world? So back to Stella for a second, we were struggling because we didn't want people walking around using Google and Apple exposure notifications and being in contact with each other for periods of time because there's COVID. So how do you simulate incredible complexity? And this is why, Ethan's kind of talking, and I was talking about digital twins. How do you create a digital twin of a system? A digital twin, we all know from Apollo 13, when Houston had a problem and our beloved celebrity, needed fixing, is they created a digital representation of the model of the space shuttle and then tried all permutations of what was available to fix the problem over here. Now, they couldn't, Tom Hanks weren't going to get out and do some welding. He can draw on a balloon, a football. That's about all he gets, and also catch COVID. But, part of it is, understanding all those permutations is a job for a computer. Of course, a model-based testing takes that kind of compute. But I'm going to kind of throw in back over to Ethan, but throw a bit of a curveball in here. Is that when I spoke to Paul Smith, Paul was kind of saying, okay, well, we go after technology, we go after lingerie first and second. I said, well, that's massively flawed based on the fact that now the caching of the search engine is going to be optimizing for those type of performance. So it's optimizing the data that you trained it with, right? And so we had this same problem with another a well-known shopping brand, where we were training the system based on data that we were synthetically generating. To your point, Paul, that Google synthetically generate the data because it didn't exist before. However, that has bias, because whatever person, developer, human makes that decision, there's a cognitive bias associated with that data set. So that, again, you're training in that bias. Whereas in the real world, it's real behaviors and anomalies of that behavior, which is the shift right kind of component. But again, Hugh would say, well, there's only 25% of all paths are covered in the real world with real data. So some systems and combinations are never done because it's exhaustive to get the data coverage that you need. So then the question goes is, if I'm taking the real world data, so if I go to, I'm going to just pick on a well-known brand, let's say, anybody got a favorite? Nike? You're wearing Nike, I can get away with that. So you go to the Nike website and you search for trainers, you're going to find something. Whereas if you go to Nike and you go for underwear, you're probably not going to find it. However, what's the reason that should it not find anything, or should it say, well, we don't do that, but we've got a sub relationship with a sub brand which does provide that. Do you want to buy it? And the buying behavior for Nike is completely different for Paul to it is to a Gen X, in the sense of they literally look at a photo on Instagram of Paul with his Nike t-shirt, they click on the image, and then they buy the item within the Instagram app, they never even go to Nike's website, or they never go to Amazon to buy it. So part of it is the shopping behavior of these multi-device experiences changed because due to not only a generational aspect or a digital skills aspect, but I'm even going to throw in an area which is, if Paul, you've got COVID, you're not feeling very happy, or you're grumpy, not that you would ever be grumpy, or you're just really happy because you just found out that you were a granddad or something, part of it is you might emotionally use an app in a completely different way, as you might get on the Nike website and say, oh, I'm going to get some baby Nike trainers or something now, and your emotional state is changing your behavior. So all of these combinations it's like, how can we even possibly think about how to start testing search? I know we've just gone through 30 minutes.
I don't think these are testing problems. I think these are design problems. So if you can't test it, I mean, there's the old adage, if you can't test it, you shouldn't be building it. And because you'll have no way of knowing that it bloody well works, So there's an old story about so all my stories are old, I'm sorry, about AI or artificial intelligence in its kind of initial format, in that the army paid some software business to put a system together to identify tanks in the forest, in the Cold War era. And so what they did is they got the army to put some tanks in the forest, and they sent up a drone or a helicopter, I should think, in those days, to take photographs, and then they trained the AI to identify tanks in the forest. Fantastic. And it didn't work at all. It did make decisions. It says, right, here's a tank, and it was like, there's no tank. And what it turned out was the photographs of tanks in the forest were taken on sunny days, and the photographs of tanks that weren't in, when the forest was empty, it was taken on a cloudy day. And so it was all it was telling you was, actually, it's a cloudy day or it's not a cloudy day. By the same token, if I'm a model, if I'm modeling Nike t-shirts and someone clicks on the t-shirt to buy it, are they choosing the t-shirt, or are they choosing the model? How do you tell? So then you've got to use ranges of. I think, well, hold on, this is getting complicated. If old guys are wearing t-shirts, I'm not going to wear blue Nike t-shirts. On the other hand, it might be, well, if he's wearing it, I'm going to wear one. And how do you differentiate the thought processes going on in the heads of the people you're trying to? I mean, you're trying to simulate the thought process of human beings, and the thought process of human beings are in personal choices, not usually rational. They're not.
With this one,
over to Ethan for a second, but just with that last statement, so a fashion retailer who I used to work for did an algorithm that changed which model. I hate using the word model when we're talking about models. I think it should be just banned, right? But what person, human, was wearing what outfit based on your requirements? Because if you were a bold, middle-aged guy, no offense, Paul, part of it is you're going to probably buy more content that is somebody with a similar build, because you can go, well, actually, I think I'd look good in that because it's another guy with a bit of a beard, bald hair, and some glasses. And you're thinking, yeah, I can see myself wearing that. Whereas if it's got a picture of a young, handsome man, then Ethan, it's completely different, right? So part of that is, if you're training the system, and this goes back to the Wozniak conversation, is it explainable AI? Are you saying, if you can't explain it, you can't test it? And if that's the case, if we can't explain it, then you can't model it, then it's not a real feature, which is what Wozniak said, is that if you can't explain to me here in simple terms what the AI is doing, then it's not a real thing. And he went on to kind of saying that in the old days, he could say to his phone, hey Siri, what time is it? And it'd say, well, it's the time, because it was doing it locally, and it had trained itself for voices asking for the time. But now, which is, my phone's not even paying attention, it's just continuing to spin round. If I say, hey Siri, what's the time? It actually goes to the internet, thinks that I could be saying a lot of other NLP related statements. And then in this case, it's still not giving me the time on my phone next to it. It's just spinning around infinitely on my phone. So part of it is that AI is digressed by its functionality, being an isolated AI system, to a connected to the internet AI system. And so therefore, being able to explain, I want to be able to ring, this is probably before my time, I want to be able to ring 150 and get a speaking cock. Was it 150, Paul? You used to have the dial-up phones like that, didn't you? The time sponsored by Accurate or time sponsored by Keysight is, 6:36. You can't go back on. People still need to know what time it is, but they buy watches, which Paul will wear a watch, whereas the younger generation have got a phone, so we don't need a phone. But if we can't actually ask your phone for the time, how do I even know what time it is? Just by looking up at the sun. So your part of the question then goes is, if you are trying to model something like what time is it, depending on the different systems that you're interacting, it could be, well, what's the system time? What's the atomic internet time? What is time? And with that kind of really difficult question, I have no idea where it's going. But Ethan, because we're getting through, could you show us something else apart from search before we get?
I'm actually going to talk about search because I think it's a really interesting topic. Particularly, it moves more into the monitoring space and shifting right to the actual user behavior treatment. And I think traditionally with tests, we're going here. I'll jump into coverage in a second and how all that works. You fundamentally will never be able to have that data, right? Because you're a closed loop system, you're never going to have the data, and without it, you can't predict, you can't generate. I think all Paul's description of creating these tests, it's effectively the brute force method of testing, right? Where you just go every single data source possible, and then now you go, how long will it take to test? About 2 years, and then you run through every single combination possible. By that time, you've got new products being released. One of the things interesting now, I think, is the bridging between the monitoring space and the testing space, right? So in, particularly, I think we have the RCI solution within Keysight and other monitoring solutions of APMs. One of the main differentiators that they come out with is dynamic baselines, or they have some AI buzzword surrounding that terminology, but ultimately it's looks at a demographic or a certain range and then looks at your moving in the pattern and the live environment, and then when you deviate from the norm, that's when it'll trigger thread code analysis, when it goes real by analysis on the actual code base itself, which will link into the actual running on the underneath architecture and the actual code base that's been running the code, and then you can pass that data back into testing to know exactly the line of code that's slowing down from the analysis perspective, and then you can feed it back. And a lot of those users, I think it's quite intuitive, right? You have your normal baseline behavior patterns, and then it's only when you suddenly do a search and it deviates the first time and it spikes up the response time, you go, okay, this is probably a analysis that needs to. The next round it goes, you either synthesize this load pattern, and they go, oh, the same pattern happened again. Now you know there's a trend, and then you can increase the testing methodology, testing methods underneath that, and then you pass it into your actual ticketing system. But I do within our fields, I think that's a massive gap that's currently missing, because the the APMs and the RUM technologies doesn't really communicate very well with the testing world, because they think of each other as a separate entities. If you pass one back, you have the self-marking your homework kind of problems. While if you go from testing to real world, they complain, oh, you don't have the real data set, you don't really understand, therefore they don't link. But reality-wise, adding that baselining in between gives you the right data set to move between the two sets. There's still fundamental problems, but really I think that's a great option. Now, what we want to talk to before about moving away from search, however, is coverage and understanding. Because of the fact that, if let's say with this environment I'm showing you now within coverage report, that's not going to show anything using live data. That's just a static snapshot of environment, and no matter how smart your machine learning is, you only can show you up to the limit of that environment, right? And within Eggplant, one of the things we do with coverage is try to give a better, smarter way of coverage reports. So I'm going to go into your coverage report, a maximum nodes, and you can see here there's different percentages of moving through the journey. And a lot of this journey is moving through the same way as if you go down the road and you want to turn left, right, this simulates all the different paths and it generates all those scenarios. I think what Paul was describing earlier about creating the data set where you have all the possible scenarios, this is, instead of the data, this is the journey through the application itself. Instead of going with a 5-character string and you changing, transposing the text into different formats, it's a 5 steps environment, and then transposing where the different steps take place. So from here you can see from welcome home, it goes to contact us, or the variation from contact or back to itself, and then going down into 4 steps, which in this way is a good way of giving coverage based on if you have an unlimited time set, right? Because ultimately, given enough time, given enough resources, this is a great way because you can add in different steps, and if you have 20 steps, then in theory you have a great coverage report. However, I think one of the biggest challenges we have with this method is time, because if you even this very simple model, there's 14,000 different paths. Right? This would probably take about 3 hours continuous running across my Mac, and then just spinning 24/7. It's not particularly fast, which is why coverage reports.
Can I ask you something? Sorry, just to, that coverage target of I can't remember what it's called now, all exploratory. What does that actually mean? What is it counting?
We won't use that term, but what we will use is, Ethan, if you go to DAI for a second, could you show us that kind of the difference it would take to do all paths, say, for instance, to give us coverage versus, extended? So here we've got a graph, which might make more sense to you, Paul, because I think I know where you're going with this. Is if you want to be able to do extended testing, which I think is what, Ethan was talking about, you want to try to do every single permutation around with all the different ones. It's going to take 152 hours, 90, I don't know what 0.9 of an hour is like, but, whereas actually just touching all the nodes is not that much, right? That's just the basic kind of all pairs, 3 hours, extended coverage. So I think that's what we're trying to see, but you see coverage over time. And our argument earlier, which was me and Paul arguing, was like, should we have always on testing, right? Should I kick off this test now, or should it just be testing all the time? And then if something, it learns, like you said elegantly, Ethan, if I'm, a new system occurrence happens, someone searches into Google for, is it legal to drive whilst watching TV, which I'm sure there's not many search Google things until yesterday. But you start seeing a spike on that because there's a lot more going to the new registration page of the DVLA. Part of it is I want to track that, and then I want to feed that into my model, which is what you were referring to with this RCI technology, real customer insight. It pull in that journey, what we've never seen before until yesterday, when they changed the law. Now the behavior's changed completely. People are going through a different flow of events, which could be different systems. It could be from the search engine in Google to the DVLA website, which is being monitored by, a APM vendor. So part of it is that telemetry information tells about the end-to-end journey, upstream and downstream across systems of systems. If we want coverage to say, how do we test that this new term that's just come in, add it to the model, and then the coverage obviously changes because the coverage you had yesterday isn't going to be the same as the coverage today because you've got a new path. The new path is a new page on the DVLO website saying, congratulations, if you happen to have a widescreen TV and a Tesla, you can now drive them and watch them at the same time. That only happened yesterday, so it changes the coverage. So back to you, Ethan, it's like, or actually, Paul, because you're asking the question, is like, how do you calculate coverage if it's a moving target all the time?
Well, I don't think it is. I think if your model is comprehensive, your model is simple, but the number of paths could be infinite. So the model is going to change over time, perhaps, as you build more software and make it more sophisticated. But it's not going to change, with overwhelmingly. It's not going to look overwhelmingly bad. But the issue is like you need advice. If you say like let's do all paths, and I don't know if that's what all exploratory means, but let's say it means all paths for the sake of the next minute. I would say, right, okay, I've got 25,000 paths. It's going to take us 3 weeks to run those tests if we run them. Mr. User, is there any value in us running these paths? And he might say, or she might say, well, there's only 2 products we're really interested in because they give us all the complexity we need. And therefore, a lot of these paths, we know that if you do these 3 things in the 6 different orders you could do, makes no odds. Why would you do them again and again and again for combinations of all? So then you start. So then, now I don't know whether Ethan can say whether the tool can do this. Probably not, but I'm pleased to tell me. But what you'd really like to do is to start colouring in areas of the graph and say, don't worry about variations in this area. Just don't go there. We trust it. Or don't. There's a dependency between something early in the model and later in the model that says, if this is true, well, whatever you do down here doesn't matter because you'll never get that far because the model will tell you not to go there, or the tool will tell you not to go there, and so on and so forth. So you've got all these kind of dependencies, and yeah, you've seen tools that do this from a purely modeling aspect, but not a test execution aspect. And it would be cool to introduce some of these features into the test execution tools as opposed to a pure modeling tool.
No.
So I don't know if you've got anything to say there, Ethan.
As we have it in front of us right now, is the effectively heat map view of previous coverage, as well as if we find bugs, issue within the code itself, or if there's a new release, we can effectively highlight that as most likely to test. I think the easiest example of this one is when there's ever a new release, it doesn't make sense to do every single test of every other solution within a software stack. You test the newest features first. If it doesn't work, then you roll it back and you try again. This, as part of this one, since you can map out where those environments are, you then test that first is the most important thing, and then you roll back to previous ones. I do like your comment on continuous testing though. I think this modeling is one of the few ways that enables and adds value in continuous testing, in the sense of if you have a continuous path testing through and you just have happy paths, it's your standard regression pack. There's only a certain amount of times you can run it. If you've got enough compute power, enough resources, you might as well just run it as soon as possible, but it's just testing the same thing over and over again. But with the fact that there's such a high permutation that's available, it makes sense to just run it in the background. In not calling my own tool monkeys hitting the keyboard, but in many ways it is monkeys hitting the keyboard, chaos testing, making sure everything, weird scenarios that commercially it doesn't make sense to do as a focus testing, but just you have the software, you have the compute, might as well run it and see if you can find those random edge cases that you'll never bother with in the normal testing cycle.
And just to jump on that, which I have to thank Ethan for the fact that he's actually just created an entire new buzzword, which I'm going to pass to Gartner in the next week event when I'm presenting, is chaos testing. I love it. Paul has hosted while we were in lockdown with Michael and James Bark, and they did actually didn't like the term chaos engineering, but actually chaos testing, I think, actually has a certain amount to it where it says, well, if we could test all of the things, and the old idea of it's not possible to do exhaustive testing, you can't test all permutations, then the question is, well, why not? But there is a kind of a guided around that. Well, what should we be doing? And what I like about what you've done here is it's kind of two things where people go up there, and it's again this top-down, bottom-up approach thing. Is that within RCI, which is the tool which learns from what user behavior is, when you pull in the model, you can pull the model in based on positive outcomes, which is what I was trying to talk a little bit about. But one of the options is revenue generation, right? So you might say, well, actually, as you can see in this diagram, what we're really caring about is that people can get into the order complete, right? But we don't really, the addresses and your downloads or dashboard, it might not be as critical path as far as a business perspective. Now, I've infinitely wrestled with, should you be prioritizing it based on a revenue / cost of the business, or should it be based on the outcome which you're trying to encourage, which is kind of what you get with like an A/B testing kind of canary rollout or a dark launching kind of thing, is we want the behavior to change. So we want people to buy more, or we want people to have an easier journey activating their TV and their autonomous car now. That is a behavior, doesn't generate you any revenue unless there's some kind of in-app, in-movie Netflix purchasing thing on your Tesla as well. But the outcome is that you want people to successfully go through registering, and I'm going to use the word because I think Paul can probably resonate with it, but tuning the TV on their Tesla. Now, I'm guessing you don't have to do that because it's going to be digital, but the joke is that you've got to get through that. Every time you buy a new TV, the first thing it says to you is, do you want to auto-tune? And you think, auto-tune what? I've not even got a cable plugged into the back of this. Is it just going to auto-tune the world, but that is an experience that you need to get through to then be able to successfully watch TV and maybe then successfully buy in-app purchases, right? But we can't just focus on revenue. And that's where, we originally had this weighting around revenue. But if you're going through the revenue, but what you find is that no one can really log in because they always forget their password. And since you did a single sign-on, now people can't do it because for some reason your Google or your SEO or your XAML kind of gateway is not working correctly for your two-factor authentication. Now it puts people off. How do you measure that? Well, you can measure off that drop rate, and you can see by the fact that the behavior is changing. And that actually order confirmation is still 100%, but that is because from a funnel perspective, is a much lower number now, because actually since you put two-factor authentication, people are like, you know what, I'm not going to go to this website anymore. I'm going to go and order it off Amazon, right? Well, they forgot their password or they lost it. Now, the reason I'm saying this, and going back to Paul Smith, not Paul Gerard, the non-fashion designer guy from Nottingham, but part of it, Paul kind of said lingerie or tech. Now, if we put that from a revenue generating perspective, and I can't really speak too much about lingerie, but from a tech perspective, a TV or a new iPhone is a heavy price tag item. And if we looked at John Lewis, we would probably say that those items would bring in the most revenue, whereas individual, I don't know, Paul, do you buy much lingerie from John Lewis anymore?
What do I buy stuff from John Lewis?
Well, yeah, what do you buy from John Lewis?
Mostly homeware stuff, I'd say. There's one near me, so very obvious place to go.
Well, if Paul goes in and tries to buy homeware, part of it is if it's been optimized for lingerie and technology, and it takes him 6 or 7 seconds to get his homeware up because he wants a new gazebo, and no one's ever clicked on gazebo, because who on earth is going to buy gazebo from John Lewis unless you're retired and do a lot in the testing world, and it's like £10,000 for a gazebo. If that doesn't load, then Paul's going to say, you know what, I've got a whole stack of time, I'm just going to buy some timber and build it myself. And he'll go to B&Q or wherever else he buys his rocks from and his wood, or he'll cut down a tree and make it. But part of it is we can't measure that journey because we're very much focused on a happy path. And I think what we're trying to say is ban all happy path and actually focus on, well, what are those ones that aren't completing the successful journeys that you're wanting to encourage? Some of them may be revenue generating, some might not be, but you need to model that in with a no bias to say the end goal is always to test payment and stuff because that's the one that makes the most money for us. But then this infinite kind of question comes in, and this is where I'm going to throw the last kind of curveball, is that if I then, in this app, add a new payment gateway, so maybe PayPal's giving me all my stuff, but actually I'm going to add in Stripe, part of it is, how do I know? Because Stripe's an upstream system. How do I know that they're actually successfully doing it? How do I measure success? I measure success going through and that people still get to order complete, but I'm not actually in control on that horrible pop-up box that I've now seen on every payment I do online that says, we've now sent a request to be approved in your bank app, and you sat there going, I haven't got my bank app with me. I'm gonna have to go and get on the phone, install it, then hopefully that 10-minute counter's not done. Part of it is you don't control that. You don't have visibility into that because it's a secure, shadow DOM, iframe, which is going off to a secure location to do your payment processing. So I say this for the same reason that I literally, I booked something the other day, and the app wouldn't actually, when I came back from going to my banking app to approve it, went back to the app, and the app screen was completely blank. And I was like, I've just paid for that, and I've just approved it, but I can't actually get back to the app. And the only way I could get back to the app was by zooming out on the app to then see the screen that was rendered correctly. And then I had to kind of hover over and just kind of randomly chaos testing, as Ethan would say, just hit all the buttons so that it then proceeded to the confirmation page. And I was sat there thinking, the reason Virgin or whoever it was that I'd ordered it from didn't test this properly is because it was never in their testing remit, because that was stubbed out as a system. and they were just hoping that it'd just work, and they always get a fast response that says payment approved because I'm testing in test, or I'm simulating in test, and that actually I can't deal with real world scenarios. So this is my kind of question back to Ethan is, what do you do for, you've got the module there, payment, but how do you deal with all that complexity around payment? And, have you got any kind of final closing thoughts? Because we've got like 4 or 5 minutes around that.
We do get that one quite a lot, particularly with payment terminals, right? Because with the good enough security, we shouldn't be able to look into it, no matter what technology it is. One of the things we do is actually just go back to old school marketing funnel, right? So we can tracking using Eggplant, going through the journey itself, using monitoring solutions. We have that gap in the middle, but we track either it's using the header or the cookie for the journey itself, which is still trackable throughout the journey. And then if there's a sudden drop off, we trigger a percentage because there's a normal drop-off amount per transaction that we can normally expect. That's the general baseline of the drop-off. If it deviates away from the drop-off amount, that triggers an alert and say, looks like something's wrong. You can't tell what's wrong, but something's wrong because your payment's getting stuck. There's something that actually we did of a large airline. So one of their problems they had was they came to us and then could see the revenue line was dropping, except everything was closing like perfectly fine. The transaction number was going, if anything, the transaction number was going higher. So it doesn't make sense. The revenue was dropping. And we found out finding out what happened because we baselined everything across their spending. And it turns out their first class tickets allowed for you to upgrade for free. And then before, loads of their customers started upgrading for free. So they were closing loads, but their revenue for the top line revenues just dropped straight down because those that would upgrade normally just got it for free. And we managed that mapping by effectively just not even testing. That's just your standard funnel conversion revenue generation. And we could see that segmented between the high rollers that would normally do the Diamond Club purchasing, all of the revenues suddenly shrank. And we could just work out instantly, oh, that's a payment issue within the upgrading process. So I think a lot of that one is even outside of the testing world, but I love using more the monitoring space, particularly for these kind of scenarios where you take it outside of testing because it's such a weird and wonderful scenarios. You just look at the normal function of the path, see the deviation away from it, and then now you have alerts that you never really built into a system, because who would ever build it in a system for testing some random drop off and a free upgrade, right? Because that's not even something that I would even think to test.
And hopefully, Ethan, you've not got to go in 1 minute because we've got a couple of questions more. But with that, I kind of want to give a bit of an example with which I think is really important. Is like what I really like about with Eggplant is that you can switch between that. So in the case of the Shadow DOM and just let's call it Selenium, right? And I joked with Jason Arbon and Tarek the other day about the fact that obviously the cure for mercury poisoning was selenium. The cure for selenium is carbon, i.e. if you have too much selenium in your system, they just give you carbon to eat, which doesn't sound that fun. But part of that is that you switch into computer vision as well as OCR. So in theory, if it goes off to a different payment gateway and there's objects you can't normally see, you could then still observe them from a computer vision perspective, identify something weird, it's all gone blank, and you spot that, which I think is really, really powerful. And then the second one is, I think, this concept around kind of the blurring of the boundaries. And I gave this example talking to a customer the other day with who kind of said, okay, well, we do pumps, right? And I know you guys do the payment pumps and you swipe the cards and scan the barcodes and do all that kind of stuff. And they've got physical robots which click the buttons and swipe stuff and do near field payments and stuff. And I think, part of it is I spoke to them and said, okay, well, that's great. But every time I drive into your petrol station, the first thing he does, he said to me, scan the code on the wall to tell me which pump I'm at, which is brilliant. Then I put my pump in it, and then says, authorized payment. Say how much you want at fuel, which is, in the US, they ask you to fuel up, pay first, then, fuel up after. But anyway, it kind of says, do you want to authorize it? And then it goes to payment. It works out the geo field of where I am. It knows what station I am. It knows by the number that I've scanned. It's ready to pump to do. And then what I find is that it connects to the free Wi-Fi inside of the garage, which I've used to drink coffee. And now I don't have an internet connection. and my payment fails halfway through the payment screen, right? And I keep on getting this every single time. And I turn around to them and say, can you just stop it, from, switching to the Wi-Fi? But of course, it's going to connect to Wi-Fi. I'm not going to get any signal because it's going to pop up their free Wi-Fi thing where I have to accept some terms and conditions and pass them an email account that I'm never going to use again. Part of it is these are different devices testing different systems, physical systems, which are pressing codes in, scanning your club card, scanning a QR code, geo fielding, working out which location of you're doing within the app, connecting the app to your payment gateway to something like, PayPal. Hugely complex system. And I know, one of the things with Eggplant is you can test anything and all of those systems in a true E2E kind of landscape. So I'm going to ask Stella this question, Ashton, but I just wanted to add those in. But so Stella, came thankfully back after a good thing I called out her name. She said, would you not run the paths that matter first before all paths? I.e., what to define what matters. And I guess that's part of that question we said about outcome-based feature clustering is what is it that matters most? And can you kind of put weightings on certain bits you want to test more of than other, bits? So if I really care about payments versus, next week I care about what sizes are selected, can you change that kind of weighting and work out what matters most to the actual users, shall we say?
Yeah, so within Eggplant, you can effectively, whether using a tagging system or you're manually weighting certain loads or segments of the submodels, it's effectively up to you to decide where you want stronger weighting. We do it automatically for you as you move through the application as the testing takes place, but it's a very easy switch to basically turn it on and then as in weighting across the system. It's funny you should mention about the cross testing as well. It's actually really exciting. We just with Eggplant and Keysight, we're now testing across both scenarios. It's the first time where historically we're still doing software testing, but now we're doing mobile-based testing using 5G with broadcasting towers. With actual battery testings, we're changing the voltage of a battery to see the response on the actual internet speed against the actual user experience. But that's a whole different topic on a different call because that's something I'm very interested in right now because we've been working with a few mobile providers building out some solutions. But exactly as you're mentioning there, weighting is frankly the simplest thing in any machine learning, right? The fact we have a weighting system is just up to you how to choose. So if for our more advanced testers, when you do a new release, we actually increase that part of the release item to automatically add in increased weighting, because then you can weigh more if you're just doing updates, and then that way you just tie it directly to the CI/CD pipeline, and I'm releasing a new payment portal update. Therefore, I'm going to give increased weighting for my payment portal submodels. Therefore, they get tested first, even if you don't visualize see it. Or on the flip side, when it's a third-party testing. Now, this is an interesting one, right? Where you can't really say the third-party releases, it doesn't tell you there's a new update, there's a release, it's just background update. You can tie that directly into your CI/CD pipeline, so that way when they send you release notes, you can press a button and it'll automatically change the weighting of a submodel in region because something has changed in the background, which has been incredibly helpful with particular things like third-party libraries, payment portals, anything like that, where it's very hard to know when it changes. It's just you're adding that manual step which you can trigger to test and change the weighting for.
I love that. Anyway, we're going to let you go, and one of the things I'll let Ethan go, and I'm going to throw a question over to Paul here. But fantastic demonstration there, and I think it shows you. And we did it live, or Ethan did it live. It wasn't us. It got to give you a great example. But you saw bug hunting there, and I want to throw this question. Thanks a lot, Ethan.